Okay, good morning, everyone. Welcome back to the online class. Hope everybody's doing well today. Today we're going to be talking about ecosystem ecology, and then I've got an assignment for you and some other due dates that we need to be aware of. So I want to start by just talking about the questions that today's work will answer. We're going to talk about what makes something an ecosystem, and we're going to look at two different definitions: the original definition, the Ecological Society of America's definition, and then we're going to talk about how energy and materials flow through an ecosystem. That's one of the most important areas of study for ecosystems. And then we're going to talk a little bit about what a modern definition of ecosystems look like that would include humans, and that's always been a topic of discussion. And then I'll give you an opportunity to think a little bit about that through the assignment. So let's move on to the lecture. All right, so we'll start here in the in the Everglades. Outside of Miami, we've got the Everglades, and the Everglades National Park is an amazing place. And I wanted to start here just because this ecosystem description, I wanted to point out a few things, right? So we've got subtropical wetland, tells us a little bit about the climate and the hydrology of the ecosystem. Spans 2 million acres across central and south Florida, tells us where it is, how big it is. Wet season tells us a little bit more about the climate. There's a dry season too then, right? And then we've got a sawgrass marsh. So as we were talking about communities in the last lesson, the dominant plant can define the community. So we're talking about sawgrass. And then we've got some other communities within this ecosystem: cypress swamps, wet prairie, and mangroves, right? And you can click that link and read more. Here's another estuary in Baltimore, outside of Baltimore. Here's some desert in Phoenix. These are all just different examples of different ecosystems. And we're going to come back to these particular areas in a little bit, but here's Boston, wetlands in Boston, Minneapolis, a national forest there. We've got Los Angeles, Cleveland National Forest here. So those are all different examples of ecosystems, and so now I want to take a minute to talk about how ecosystems are defined, right? And so the first use of the word ecosystem was by this gentleman Tansley in 1935, and he defined it as the basic unit of nature on the face of the earth. And I think one of the things to think about is that ecosystems can be at any scale. That the whole earth could be considered an ecosystem, but then at the same time the inside of your ear and the microbiome there could be considered its own ecosystem, because it's really just any sort of delineation of the combination, the interacting organisms in a physical environment. And generally defined by vegetation, soil, and climate. But the inside of your ear may not necessarily have soil, but it's got its own environment, right? And so the Ecological Society of America defines ecosystems as this. So it's a little different, but same idea, right? And kind of expands it so that we could include more things other than terrestrial ecosystems, right? So geographic area, all the organisms, non-living parts, right? And so they give some examples, and one of the things that's interesting is that they put here that the more natural an ecosystem is, the more ecosystem services it provides. And so we went over that, but ecosystem services are the jobs that an ecosystem does for people. So they're starting to work in people into this definition of ecosystems, right? Cleansing the water, the air, crops and important plants, pollution control. So those are two definitions of ecosystems. And another one that I like is the ecoregion. And so we're looking here at a map of the United States, and these ecoregions kind of correspond to the hardiness zones. So this is a measure of climate, specifically temperature. The higher the number, the warmer the climate, and it's marked out by the last frost date and the earliest frost date, so you can kind of pick out where you live. But Here's a specific map of New York's ecoregions, and if you know New York's geography, that this will help you understand a little bit about or geology. Excuse me. You've got the Adirondack Mountains in the north, so that's why we see those different ecoregions there, and some kind of micro areas formed by the microclimate and the elevation of the mountains. So those are the landforms in geology. The soils also impact the ecoregions. We've got kind of that line, glaciation line there. Vegetation, climate, land use, wildlife, and hydrology are all included in ecoregions, but are also all variables that can be considered in delineating an ecosystem and thinking about what an ecosystem is, right? And so we're going to take a look at one particular ecosystem right now, and so it can help us think about the flow of energy and materials into an ecosystem, right? So if we this is a Florida Springs ecosystem, and some of the organisms there are labeled, some of the key animal species anyway. And I just got some pictures. I got a chance to visit one of these 2 summers ago, so it'll just add some imagery to that diagram, right? So as we look at this, we can think about how materials, so the water, where's the water coming from? Coming from underground springs, but where is it going? What energy, solar energy, where is it coming from? It's coming from the sun, but then where is it going once the plants incorporate it? And some of the pioneers in thinking about these sort of things were these 2 guys, Eugene and Howard Odum, that did work in Georgia. And I want to specifically focus on the work of Howard Odum. I'll go back to that slide in a second. But he was one of the pioneers of systems thinking, and this idea that we can model systems through diagrams, right? So he developed this language even called energies for doing it. I don't go that deep into it, but I use a lot of his thoughts about modeling systems where we can kind of delineate what a system is, and then within it identify other systems, and that's one of the things I'm going to ask you to do, and then start to draw some arrows that show the flow of energy and materials, right? And so he also pioneered this idea of ecosystem energetics and ecological economics, and more people are recognizing how important this is, that ecology and the relationship between organisms is an economic one, that there's energy that flows in and energy that flows out, and materials that flow in and materials that flow out. And so managing that and understanding it helps us better understand ecosystems and our own economy. And so this is another diagram that he drew of that ecosystem that we were looking at, the Florida Springs ecosystem. And so if we take a minute to examine this, right, we've got arrows. You see lots of arrows, and the larger, the broader kind of the flow, the larger the flow. So this shows us the amount of sunlight, and it shows us that photosynthesis captures that energy and moves it into the plants. It's kind of this box here is a plant, and then we've got flows out as heat, and that's something to really pay attention to, that most of the energy leaves the ecosystem as heat. But over here we've got some of the energy that flows into the herbivores, then to the carnivores, the top carnivores, the amount reducing each time. We'll talk more about that Thursday. And then eventually anything that's left is going to end up with the decomposers, or be exported out of the ecosystem or turned into heat. So this is just one way to represent the flow of energy in a way that's quantifiable. So just look here. This is a diagram of a human system included in the blended in with the natural system. So we've got over here forests, grasslands, deserts. The sun feeds all of those, but then we've also got different human activities here: electric power, transportation, manufacture, right? And so things can get really complex really quickly. And this just simplifies things a little bit, backs it up a little bit. And if we just compare the way Howard Odum diagrammed 2 different human communities, we've got one that's kind of a more, the energy comes from the sun in this one, and the top one, and then the bottom one, we're getting a lot of energy from fossil fuels, and so you can see um, that has shifts the way energy flows significantly, and it's an important thing to consider. So as we talk about energy, there are a couple of different things that we need to think about. Um, the laws of thermodynamics say that energy cannot be created or destroyed, can be changed from one form to another. So, for example, plants change the light energy into chemical energy, and living things can change chemical energy into motion. And there are a variety of types of energy, and so energy can move in between all of these different things. For example, potential energy and kinetic energy are related in that we can use potential energy and its transformation into kinetic energy to create electricity, electromagnetic energy. Electromagnetic energy can power our phones, which then means that it's converted into maybe sonic energy so we can listen to music, or light, which is another form of electromagnetic energy. All right. So let's keep moving. So laws of thermodynamics, all systems are moving towards disorder, the law of entropy. And so this basically just says that we need to keep an energy input to maintain the organization of our body. And at the same time, that not all the food is used, a lot is lost as heat, which is kind of a disordered form of energy, right? And so Howard Odum came up with this law number 4. The first 3 laws are time tested, but he came up with this idea of maximum power principle, and that in evolution, fitness is maximized when an organism is able to capture and use the most energy possible. So it gets into the ideas of return on investment, that you've got to be able to get as much energy as you can with as little possible activity, right? And so one of the things that helps us understand this idea is the idea of gross primary productivity and net primary productivity. And so an important thing to know is that most ecosystem energy was originally solar energy, right? I've said that once already. I'll keep saying it again because it's really important. And one of the other things that's frequently a misconception is that most of the mass in our ecosystem was originally atmospheric carbon. So trees take in carbon dioxide, incorporate that into sugars, and then turn that into stems, leaves, flowers, seeds, all of those different things that then consumers eat. So gross primary productivity is the measure of the energy captured by photosynthesis, and then net is what's left over after the plant uses some of that for respiration and growth and everything. So it's the net primary productivity is change in above ground biomass over time, and it can be helpful to think again about this like economics, that gross is how much money your business is taking in, and net is how much you have left over after you've paid all your bills, and the net is what you can use to build your business even more. So now I want to switch to thinking about this idea of how humans fit into the idea of ecosystems. And so we've got back to Tainsley in 1923. He considered the role of humans and whether or not humans were damaging ecosystems, and he laid this out. Not the ecologist's role to concern himself with hindering human activity, right? Whether it's destructive or otherwise, because at the end of the day, it's just a change in the relationship. That every activity just means that there are opportunities for other organisms to grow, and it can be a form of succession or disturbance that just leads to a change. It's not, in his view, not necessarily a bad change, but it helps frame the idea of, if we're going to think a little bit differently about our role as people, and specifically urban ecosystems, how are we going to incorporate that into a view of what an ecosystem is? And so here's a new definition of ecosystems that include social factors, right? So we still have the biological and physical, but we integrate in the idea of people and how people interact with each other and their environment into our definition of an ecosystem. And so when we think about what this means, we've got our patterns of human infrastructure. This is defining characteristics of an urban ecosystem. Well, we've got vegetation structure, aquatic features, and climate, right? And so then our social influences on land use. So how do people impact this? We've got housing density, income, education, lifestyle policy, land use history. So these are all the things that can influence what an urban ecosystem looks like that are beyond just biological factors. And I also just wanted to take a minute because to start to develop a little more ecological definition of an urban area and an urban ecosystem. Oftentimes we have our own kind of social thoughts about what an urban area is, often not good, and our media reinforces that. But I propose that a lot more of us live in urban ecosystems than we would potentially think about. So according to the census, an urbanized area, place where 2,500 or more persons reside. And so we've got on this map, we can see like Monroe County the whole thing is considered urbanized, right? And then we look closer at New York, we've got urban areas, a lot more urban areas than people would think about. Ithaca is considered urban. We've got also our cities here, and I like this in New York. We've got shows us how the land use history and has impacted the locations of cities. That the Erie Canal between Albany and Buffalo means that we've got some evenly spaced cities of Utica, Syracuse, Rochester, and Buffalo, all pretty much in a straight line. All right. The other thing to think about is housing density, how close houses are. And again, this is just a map of all the urbanized areas. And then this is the U.S. Geological Survey's land cover definitions. And so anywhere where we see the red is an urbanized area. It's easy to see if we look around Chicago or Detroit. And then here again is Rochester with a map of what urbanized areas according to the USGS. And then I think it's also important to think about the social aspects of everything and how race and economics influence the ecosystems that we see in urban areas and how we interpret that. And so these are just some maps that show how people are distributed racially in cities. On the one side, we've got New York City. You can find Manhattan by finding a big rectangle that is empty, where no people live, in the middle of the island there. And then over on the other side, we've got Rochester. And just these patterns of human residence just give us something to think about when we think about the interactions between people, the relationship people have with each other and their environment in an urban ecosystem. And then these are just some maps of how economics and education play out in different areas. The brighter colors mean that these are zip codes where people have a higher education level and income level. And then if we look at Rochester specifically, one of the things that's really interesting is there's just a stark line between the dark colors where we've got low income and low education, and the brighter yellow colors where we've got high income and high education. And again, just a way to think about how that impacts the environment and people's relationships with each other and their environment. Broadens that definition of what an ecosystem is. And so then I want to just wrap up with this thought and just show you these. And so when we think about urban ecosystems, we've got 6 different areas of the country right here, urbanized areas of the country. And this is what they all look like from above, from Google Maps. Now, directly next to them, this is what the natural environments look like. There's some human impact. You can see some roads and stuff. But this is what the natural environments look like. And so if we take a minute to think about each of these is uh, the areas of the country we started with today, right? So we've got Baltimore, Phoenix, Los Angeles, Miami, Boston, and Minneapolis. And people have started to study these ecosystems and compare the human urbanized ecosystem to the natural ecosystems, and have found kind of two trends that are really interesting. One is that the ecological similarity, there's a greater ecological similarity between the urbanized areas in different parts of the country than there is between the urbanized area and natural areas that are near each other. And so what that means is that a neighborhood in Phoenix has more plants and animals that are similar to a neighborhood in Boston than the plants and animals that are in the desert nearby. And so this kind of homogenization has interesting implications, right? You know, we've got Boston, natural areas near Boston versus the neighborhood there. And then the other thing that they found is that, in urbanized areas where there's affluence, there's actually less plant biodiversity than there is in urban areas, densely populated urban areas with less affluence. And that can be related to a couple of different things. One is just that people that don't have the money to kill every plant that's not a grass or some desirable tree means that there's a lot more diversity that's able to grow. And then the other one is people make more interesting choices living in cities about what they have in their yards, that there isn't the social pressure to conform. And so that allows people to plant gardens and also kind of attract people that want those kinds of things. So if you want to look at these maps, they're there. All right, so now on to the to-do list. You've got a couple of different tasks today. Make sure you read all of chapter 46. The points are going to be, the whole chapter's assigned at some point through the next 2 weeks before the exam, so you might as well just read it all at once. And then I've got assignment 6, which I'll talk about a little bit. That's going to be due April 12th. Quiz 5 is also due April 12th. And then just want to put April 16th, exam 2 about ecology, be essentially everything we've learned since we've come back from break. And I'll put together a review guide by Thursday. But before I wrap up today, I just want to take some time to talk a little bit about the task that I've assigned for you, or the assignment that you need to do. I want to make sure that I'm clear in calling it an assignment because it's going to be graded. And it's something that you're expected to turn in. There we go. And also with the deadlines, I'm trying to be as flexible as I can with deadlines. I will let you have extensions without penalty, but it's important that you let me know that you're engaged and that it's that you're not just letting everything slide. All right, so assignment 6 is for you to diagram your home ecosystem. I think that this is a good exercise as we all spend more time at home, but I'm going to let you define what home is to you, because I know some of you are in situations that you wouldn't consider home. And maybe home to you is the middle of the woods somewhere. And so I'll let you define what home is. Starts with just asking you to define what an ecosystem is and the different elements of an ecosystem from this lecture. And from there, you're going to define your home ecosystem, review the different characteristics of an ecosystem. So you think about physical boundaries and biotic and abiotic elements of your home ecosystem. Anywhere you can use quantitative measurements is a good idea, including things like temperature, what's the average temperature, stuff like that. And then the next step is to identify the energy and material reservoirs in your home ecosystem. So if you go back to the slideshow, you'll see that one diagram that you define the system, and then within that, what are the elements of the system, right? And from there, I want you to think about 10 material and energy inputs to your home. So that's can be the building itself, or if you want to define your yard as part of your home. But then think about each person or living thing within that too, or even the technology, right? Your computer requires some sort of energy input. And then the same is true for the outputs. You need to identify inputs and outputs. And then I'd like you to identify 5 material and energy transformations. And then the final step is for you to create a systems diagram for your home ecosystem. There are lots of different ways to do this. We've been kind of diagramming systems this semester. So I know you've got a little experience, but don't worry about too much whether or not the format is right. I want you to just incorporate these ideas of, what's the system, how you're defining the system, what are the different reservoirs or places where energy and materials reside in the system, what the inputs and outputs are, and what sort of transformations, processes are happening to change the material and energy. So good luck with that. I want to make sure that if you need any help, you reach out. We've got office hours and LA sessions, and good luck with all your classes, and let me know if you need anything. All right, have a good day. See you later.